In this video, I want to introduce two tail tests for hypothesis testing. Ever since we started looking at hypothesis testing, we were looking at one-tail tests. And effectively, what we're doing in our one-tail tests was that we were either looking at something like this, where we were looking at the 10% at one tail, so maybe the significance level is 10%. Okay, so that was a one-tail test, or we were looking at it from the other direction. Okay, where this was 10%. But now we're going to look at a two-tail test. So rather than looking at 10% at a specific end, we would look at 5% either side. Okay, so this would incorporate to be 10%, okay, and be a 10% significance level, but we're looking at 5% either side. So we split the significance level percentage in half and look at it from both ends of the binomial distribution. Now, why would we do this? Well, the problem is different in the context of a two-tailed test, okay? So let's say, for example, you're flipping a coin and you want to determine whether heads is going to be more likely in coming up, okay? So we've looked at this type of problem already. We looked at hypothesis testing in this context a few videos ago. And for that, this is a one-tail test because you're looking at whether heads specifically is more likely or not. Okay, or you could do it from the point of view of tails, if you like. Now, if you were saying, well, I'm going to flip the coin, but I don't want to look at whether it's heads or tails. I just want to determine whether the coin is biased in some way. Well, in that case, because you're not looking at a particular tail, okay, you're not looking at a particular situation, you're just trying to determine whether that null hypothesis is wrong or not. Not necessarily that it should be greater than or less than the null hypothesis, but whether it is different from the null hypothesis. So rather than having a situation where we have the null hypothesis being equal to 0.5, for example, and the alternative hypothesis being less than 0.5 or greater than 0.5, the situation that we're considering is where the alternative hypothesis says, well, we don't think that the null hypothesis that p is equal to 0.5. We think it's not equal to 0.5, okay? And this is the situation that we're going to be looking at in the next few videos, okay? And trying to determine how this is going to influence the process that we go through.